Let's check the very standard mathematical form of definition of continuity. This is given by Cauchy. So we call it as Cauchy's definition. Now what does this Cauchy's definition says? All that what we learned now is now put into mathematical form. A function f is said to be continuous at a point A if for every epsilon greater than 0 there exists a delta greater than 0, and remember this epsilon and delta, how are they? Epsilon and delta should be both real numbers and they both must be as small as possible, because these things would denote as something called neighborhood. Now, what does this definition says? For epsilon and delta greater than 0, as mod x minus a is less than delta, mod f of x minus f of a should be less than epsilon. Now let us see what does this mathematical definition by Cauchy has to do with the explanation which we have taken till now. Now let's consider the first statement. Mod of x minus a is less than delta. Now what does this mean? The value of x should be between a minus delta to a plus delta. Yes, you are recollecting correct. This a minus delta to a plus delta is nothing but a neighborhood of a. So if you read the statement again, mod x minus a less than delta means x should be in the neighborhood of a. The value should be in the neighborhood of a, very close to a, to an extent on the left side and to an extent on the right side. So when x is in the neighborhood of a, what does our second condition says? Mod of f of x minus f of a should be less than epsilon. Again, if I convert this to intervals, then f of x must be from f of a minus epsilon to f of a plus epsilon. So shall I say f of x must be in a neighborhood of f of a. Now let us see what is the final meaning of this. When x is in the neighborhood of a, that is when x is very close to a, let's write the formal definition. When x is close to a, both from the left as well as to the right, when x is very close to a, then f of x is very close to f of a. That's what is the meaning conveyed by this definition, right? So when your x value is close to a, your f of x value is close to f of a value, then the function is said to be continuous. That is, as x is approaching a, your f of x is approaching f of a, which is the functional value at a, then the function is said to be continuous. So this is again an extension from limits, that if your left hand approachability and the right hand approachability both are nearing and at the same point, even f of a is also taking the same value, then the function becomes continuous, right? So Cauchy's definition, the three conditions for continuity and the graphical form of continuity, all three of them lead to the same definition. Is that idea clear? Right.